So we're going to build on the previous video and continue down the OSPF path and talk about exactly how OSPF picks its neighbors. Now I'm examining this topic in depth just because OSPF neighbor selection is perhaps one of the things that confuses network engineers the most. I've set up this OSPF network, and yet I've got these two routers that should be neighbors, but they're not neighbors. Why are they not neighbors? Why don't they work? Why doesn't it just work? Well, if it was easy, anybody could do it, I guess. So we're going to go through the neighbor selection process in sufficient detail at the CCNA level to allow you to do some basic troubleshooting when we have neighbor relationship issues. When we get into the lab, I'm going to purposely break some of the configuration so you can see what happens when OSPF routers don't want to become neighbors. So, as a bit of a review, like EIGRP, OSPF maintains a neighbor database that's used to determine when routes and routers go down and react accordingly. It does this by using the hello packets that are sent every 10 seconds. That every 10 seconds is called the hello interval. That hello interval can be tuned to be higher or lower depending on your network performance needs, but in 80% of the cases, the default hello interval of 10 seconds is more than sufficient to assure network stability. OSPF knows that a router is down when the dead interval expires. Now, the dead interval defaults to 4 times the hello interval, or 40 seconds. So essentially, if I am an OSPF router and I have not heard a hello packet from one of my neighbors in 40 seconds, then I know that guy's probably down. He's missed 4 hello packets in a row, and so therefore I'm just going to mark him as being dead. I'm going to recalculate my local link state database and route around this failure. Now, hello packets contain some crucial information about the sending router. First is the sending router ID, and we'll talk about the router ID here in just a few seconds. We have the area ID, and we'll talk about areas elsewhere in the course. We also have the hello and the dead interval, that 10-second or 40-second timer that helps us to know when a router is up or down. We also have the router priority, which is used for DR or BDR election. We also have some information about the designated router and the backup designated router and other neighbors to this particular OSPF host. Now, as I mentioned previously, just because neighbors can exchange hello packets and they decode these hello packets doesn't mean that they'll actually become neighbors and start exchanging routes. It's just like when you move into a new neighborhood, you'll move in and talk to all of your neighbors. You'll like some, you won't like others, and the ones you like, you'll start conversing with more and more, and the ones you don't like, you'll just kind of wave to them as you go by them in the street. OSPF's kind of the same way. When a new neighbor is discovered, OSPF compares some key parameters between me and the router sending the hello packet. If these parameters don't match, then a neighbor adjacency is not formed. The parameters that it looks at is the subnet mask and number, i.e., are we on the same subnet? Do our hello and dead intervals match? Because if the hello and dead intervals don't match, then I might be expecting a hello packet every 10 seconds, but he's only sending them every 20 seconds. Therefore, if he misses one hello packet, then I'm going to think he's dead, and I'm going to take him out of the link state database, when in reality, maybe there was just some network congestion, but he gets the third one, and so that's why the hello and dead intervals have to match between OSPF neighbors. The OSPF area ID, basically, are we in the same area? Do we have the same copy of the link state database? We also have authentication parameters, and OSPF authentication works almost identically to EIGRP authentication, so we won't actually implement OSPF authentication here at the CCNA level because, quite honestly, it's not covered on the exam. And finally, the stub area configuration. Now, we will not cover stub areas at all at the CCNA level because that is more of a complex and advanced topic. If you really want to know more about OSPF stub areas, you can go on to the CCNP courses and coursework, and you learn all about stub areas and not so stub areas and totally stub areas, and I won't get into that right now because it can cause you to have a headache, I guess. Now we'll pause with our discussion of OSPF neighbor selection right here, and we'll pick it up in the next video.